Welcome to a video on Apache Kafka. In this video, we will look at the following topics. What is Apache Kafka? Use cases of Apache Kafka module, the terminology involved, installing Apache Kafka module in decisions, setting up the message queues, and the steps involved. What is Apache Kafka? It is an open source distributed event streaming platform used for high performance data pipelines, stream processing, and real time data integration. It is a system that lets you publish, store, and process streams of records in real time at a massive scale. Use cases of Apache Kafka. It is commonly used for data pipelines, moving data between systems, example, microservices, databases. Real-time analytics, feeding data into real-time dashboards or analytics tools. Event-driven architecture, triggering actions across systems when something happens, like a user signing up. Logging and monitoring, collecting and analyzing logs across distributed systems. Terminology in Apache Kafka. Producer sends data, example, events or messages to Kafka. Consumer reads data from Kafka. Topic, a category or feed name to which records are sent and from which consumers read. Also, refer to this diagram for topic and partitions. Partition. A topic is split into partitions for scalability. Broker. A Kafka server that stores and serves messages, as shown in image 1. Cluster. A group of brokers working together. Offset. A unique ID for each message in a partition. Now let us look at how to install Apache Kafka module in Decisions. For that, open your Decision Studio and navigate to Settings, Administration, and Features. Search for Kafka module and click on Install. After the installation of Apache Kafka module in Decisions version 9, this module needs to be added as a dependency to the project. For that, at the project level, expand Manage, Configuration, and click on Dependencies. Click on the Manage button and the Modules tab to add decisions.kafka as a dependency. Click on Confirm to close the editor. Once this module is added as a dependency, the steps provided by this module will be available in the Flow Designer for use. Now let us look at how to set up the message queues. For the demonstration purposes, I have created a project exploring Apache Kafka here. In the project, expand, manage, jobs and events, messaging, and we will find all the settings related to the message queues. Please note that I have set up the Kafka messaging system in my local. Now let us connect the decisions environment to the Kafka system running on my local. For that, navigate to settings and edit Kafka message queue settings. For the servers, I have given the host as localhost and the port as 9092 since this is where the Kafka message system is running. For the message queues, I have created two queues here. My topic queue, where the producer will produce the messages and a message handler in decisions will read the messages. I have also created another queue where the producer will send the messages, whereas we will not have any message handler to read the messages. The idea here is to explore how the steps work for each of these queues. Now, set up a queue handler by using this button. Here, I have set up a handler with a handler name new message handler, and the handling technique would be get. We will discuss about all of these options towards the end of this video. The active flow count is 1, where one message at a time will be read. The message queue would be my topic queue. For the handler flow, I have used a step get strings from UTF-8 bytes, which will convert any payload into a string format. I've also used a log step to confirm if the message handler is actually getting triggered or not upon receiving a message in the queue. Save the settings. Now let us look at a demonstration of the Apache Kafka steps used. I have a flow here to explore all the steps. Using this flow, let us explore all the module steps related to the queue, my topic queue, which triggers the message handler whenever any message is received from the producer. So for the settings, give the queue name as my topic queue and give a random message text. The output of this step is a message ID. Now, as you see here, the message is already sent to the queue. Access the logging report to confirm whether the message handler is being triggered or not. As you see in the log report, we have a log step with the message that is just sent. Similarly, let us explore the other steps. Post message. This message would take the content as a list of bytes and posts it to the queue my topic. Debug this flow to see the result in the log report. As you see here, the list of bytes is given in the log step. Similarly, let us use the step get message on the queue my topic queue. And as you would debug here, you will notice that there are no messages in this queue. This is because the message handler has already read all the messages from the queue. You will observe a similar behavior for get message count, where the message count would be 0, get string message, which will take the no message outcome path, as no messages are there within the queue that are to be read. Let us now explore the steps for the other queue, which is another queue, which is not attached to the message handler, and therefore the messages will be intact within the queue. So let us post a string message to this queue with the queue name as another queue, and the message text would be this is another message queue. Let us explore the same steps with the second queue named another queue that is not attached to the message handler. All the messages that are published into this queue will stay intact without being read. Now let us post a string message using this step to the queue another queue, and the message text would be this is another queue message. Debug this flow and cross verify in the logging report. As you see here, the message handler has not been triggered. As you see here, the message handler is not triggered. The post message would also work in a similar fashion where it will post the list of bytes to the queue. Let us explore the step get message count. Configure the queue name to be another queue where the output is the message count. Debug this flow to see the output here. As you see here, the message count is 4, wherein 3 messages were already there within the queue and an additional message has been added here just now. Get message and get string message are the steps used to fetch the messages from the queue. The only difference between these two steps is that get message will produce the output in the form of object of type message queue message. In addition to the message that is being received, we have other metadata related to that message, whereas the get string message will get only the message in a string format with no metadata available. Now let us look at the message handling modes used while setting up a message handler. Lease receives a message from the queue. The decisions tool will send an acknowledgement to the queue once the message has completed processing. Lease with expire shares the same behavior as leased with the addition of sending not acknowledged signals. There are two ways messages can time out. The message handler flow throws an exception or the communication between decisions and the message server is broken. Get retrieves a message from the queue. The message will be processed and no acknowledgement will be sent to the queue. This is the message handling mode we have used in our demonstration. Get and remove retrieves and removes a message from the queue without sending an acknowledgement. Please note that the concept is the same for all the messaging systems available. This was a short video on the messaging systems and Apache Kafka module. Thank you.